I say a little bit. If you want, you can see his CV. Actually, I would like to show Google Scholar as you see.
So you make use of IT.
Sorry.
You make use of IT. You pick up everything quickly.
Yeah. Actually, Professor Shakir Ali, his area is derivation in rings, near rings, and algebras, functional identity, and then coding theory and cryptography. Actually, his paper cited too many things, as you see, over than 3,000 cited, as you see. I would like to give to this speech. Can you go ahead? Let's starting, please.
Okay, thank you very much, Professor Kurle, Chair of the International Congress Fundamental Applied Sciences, for giving us this opportunity to speak in the front of the galaxy of mathematicians around the globe by this way. So first I will share my screen. Okay, and it is visible, Professor Kurle? Okay. So, dear colleagues, ladies and gentlemen, today I speak invariance property of the minimal prime ideas. In fact, this works, we close a new old problem, we make connection with the old problem with the new one. So the old problem is basically one of the most important work that is, on Singer-Burmer conjecture. Basically, this is in the setting of functional analysis. Now, how to make the current problem in the ring 30 version. So we are talking about algebra and functional analysis connection. And this work, we go along this outline. This is the brief outline of my discussion. And then these are the papers which motivated us to work in this on this problem. So look at paper 1, image of derivation contained in the radical, one of the most and classical result improved by Thomas in the year 1988, and it's later on it is very famous conjecture known as Singer-Burmer conjecture, followed by the Singer-Burmer, and then it is known as Singer-Burmer conjecture. And the last 3 papers, you see 3 and 4. 4 is my paper, because I write down the Singer-Burmer conjecture in the setting of some other type of derivations, followed by Bracer and A.R. Varina, and then proved some more result on Sinclair paper, that is paper continuous derivation on Banach algebra. So these paper be combined in the new setting of study, and that is we make connection with the ring 30 version of functional analysis. So let me come on briefly some key definitions, that is, common algebra. Basically, I give giving these definitions because some of us maybe not from the background of algebra. So just briefly write down what terminology we are going to be used during our discussion. So I make it easy for those who are not aware about all these things. So this is what algebra, I think most of you know, and then when the algebra is called commutative. If xy is equal to yx, for all x and y in A. And algebra has identity if it satisfies the identity Ex is equal to Xe is equal to X for all X in A. Banach algebra is a linear algebra as a vector space, is also Banach space with the norm satisfying the multiplicative inequality. That is, norm of X by is less than equal to norm of X and norm of Y for all X by in A. In other hand, Banach algebra, the complete norm space we call Banach algebra, is more general definition you can use. Then we come on most important definition related to the present talk, that is the primitive ideals. Okay, so let A be an algebra, and primitive ideal of an algebra A is defined as the annihilator of a simple algebra, a simple A module. So this is, and then we make connection with the ideals and primitive ideals and give some example and counter examples. That is, the every primitive ideal is an ideal. However, the converse need not be true in general. And then I'm audible to all of you, please, Professor Korle.
Yes.
Okay. So every primitive ideal is an ideal. However, the converse need not be true in general. Let us see some examples for more justification. Consider ring of integers and take M is ZP, where P is prime. Then this M regarded as we all know, ZP is fit. Okay, so of course, then M is a simple Z module, and the annihilator of this module M is nothing but the ideal generated by P. So then this PZ is a primitive ideal of R. And then if you look at the means the ideal which is not primitive, means connection. So again, we consider the ring of integer, and the ideal generated by even number, that is 4. So 4Z is an ideal of Z. However, it is not a primitive ideal of Z. That means the concept is not very similar. So it is reasonable to study the concept of primitive ideals in the present setting. Radical of algebra means it is the intersection of all primitive ideals, and algebra is said to be simple if radical is 0. So moreover, an ideal P of R is said to be prime if P is not equal to R, and for x, y belongs to R, x, y is 0 in P implies x in P or y in P. And of course, every primitive ideal is prime, but converse is not true in general. So let us look at example. Consider the ring of integers, one of the most important ring we always consider. And of course, 0 is prime ideal, but not a primitive ideal. And then we come another definition, the minimum prime ideal. So prime ideal P of R is minimum if P does not properly includes any prime ideals of R. So let us see the 2Z when R is ring of integer, the prime ideal and which is not a minimal ideal of R. Then with this, let us give the idea, because connection of derivation with today's talk. I'm sorry, I can offer you tea virtually, not properly. Tea virtually. Okay. So let A be an algebra. A linear map D from A to itself is called derivation if it satisfies the Leibniz rule. And of course, it called a bounded derivation. Then it satisfies the additional condition that it is, you see, the norm of D is finite. Then we call D is bounded derivation. So every bounded derivation is derivation. However, the converse need not be true in general. So we have a counter example. Let us look at that. Means there exists a derivation which is not always bounded. So for this, we consider the ring of polynomial over reals and define the map. This type d of fx is f d, the usual derivative. Then d is the derivation on R which is not bounded. Okay, so this is what we call it unbounded derivation, because it is the bounded derivation has very good connection with the problem of conjecture due to the Singer and Verma. So that's why the notion is very, very important in the discussion. In the year 1957, Singer and Verma established a very classical result in the setting of Banach algebra, and the result which we want to state is the following. Let A be a commutative Banach algebra. As I mentioned, the algebra is said to be commutative if x, y is equal to yx. So this is the setting of in commutative Banach algebra. Another is non-commutative, discussed on separately. First, we discuss the commutative version, and then we discuss non-commutative version of that problem. So let A be a commutative Banach algebra and D a bounded derivation on A. Then D maps A into Jacobson radical. What does mean? That means the range of D are, DA contained in Jacobson radical. And very interesting, if Banach algebra is simple, then the DA is 0. That means derivation becomes a 0. So similarly, in that D is 0 in case of simplicity or simple Banach algebra. Now, moreover, they put forward the conjecture, and this means make connection of derivation and analysis, and this problem or this theorem commonly known as Singer-Verma conjecture in the literature, and it was proved in the year 1988 by Thomas, and it was published in Annals of Math, one of the most prestigious journal in mathematical sciences. Later on, this conjecture, open lot of direct researchers in various settings. So, in the year 1988, Thomas established the validity, means there are, this conjecture is still open in some sort of sense. At that time, it is also not completely solved. So in the year 1988, Thomas established the validity of this conjecture for derivation of the arbitrary nature. That means instead of the bounded derivation, Thomas tried to check it for arbitrary one, that means without boundariness. So look at the result that was proved by the Thomas, that is for every commutative algebra, the image of bounded or unbounded, that means arbitrary derivation, contained in Jacobson radical. So in the previous result, the main conjecture is related to the bounded days, that means derivation which is bounded, then its image of that one contained in Jacobson radical. But now this result in the setting of for the arbitrary derivation, that is true for bounded as well as unbounded derivation. So there is as already give the examples of derivation which is bounded as well as unbounded. Okay, so the example we have quoted, this is bounded, sorry, unbounded derivation, but there exists the bounded derivation as well. And then there are several ways to extend the Singer-Burnham theorem to the commutative Banach algebra. And in the year 1969, the Sinclair proved as result for the continuous derivations for non-commutative Banach algebras. That means every continuous derivation on Banach algebra means commutative as well as non-commutative over reals or complex field leaves the primitive ideals under invariant. That means if P is a primitive ideal and D is continuous derivation, then the image of D in P. This is the meaning of invariance. So that this make connection with the title of the paper, okay, invariance property of the ideas. So that this is what the first result in that contest. In the same year, Sinclair continuously established the theorem for more general case, and he considered a Jordan derivation instead of derivation. And of course, every derivation is Jordan derivation. However, the converse need not be true in general. So this result is more general than the previous one, and the result which we want to state is the following: a continuous Jordan derivation on Banach algebra leaves invariant primitive ideas in the algebra. Moreover, this result was extended by Cossack in 1977, and he proved the result, that is, let D be a derivation on Banach algebra A such that such that this separating space J of A is nilpotent, and then D is contained in P for all primitive ideal P. So that means he take the condition. Of course, he considered derivation in arbitrary setting, and instead of J, he considered is nilpotent, that nilpotent as an ideal. Then dP contained in P for all primitive ideal P of A. And then in the first non-commutative extension for the Singer-Burnham theorem was proved by Youth in the year 1984, and the result is every continuous linear derivation D of non-commutative Banach algebra which satisfy the additional condition, that is dx d by in the radical of A for all A, x and y in A, then D maps A into the radical. Further, we give the more different type of derivation. That is, the derivation D is called centralizing if it satisfy x, dx belongs to J. So you know this is the leap product. In fact, that means if you open this bracket, so this is x dx minus dxx. Okay, and such type of derivation we call centralizing. So in the year 1981, Matthew and Murphy established the old problem for centralizing derivation, and he proved the following result. That is, you see, let D be a bounded derivation on Banach algebra A, and then A dA in the center of A, then the image of D contained in the radical. And further, there are in the subsequent year, people extended this result in various type of problems and the settings. So we skip something because of the time, and we move some results from the generalized derivation. How the Singer-Balmer conjecture is valid in the case of generalized derivation. In fact, generalized derivation is a generalization of derivation, and it is very important because it makes connection of analysis and algebra. If you look on the definition, so look at the idea, this type of map, you look here, this type of map we call the left multiplier, in fact. So the first part, this is the left multiplier, and the second part, the right multiplier. So if we combine the left and right multiplier and we define like that, then such type of map we call inner generalized derivation. And after making this connection with the inner derivation denoted by that is IA, where fixed element A of A, and x in A, here is A means x, or you can take a ring, is not column. Then the little bit calculations give the idea of generalized derivation, and this idea is defined in the year 1989 by Matthew Brescher, one of the key mathematician who did lot of work in the setting of derivation in algebra as well as analysis. So let me define more precisely. A linear map G from A into itself is called generalized derivation if there exists a derivation D of A such that dxy is equal to xgy and dxy for all xy in A. The more importantly, if you look as I showed you in previous slides, if you take this D is 0, that means zero derivation, then it look like right multiplier, okay? And if you take similarly, means the theory of generalized derivation make connection of the left multipliers and the right multipliers, and the theory of left multiplier or the right multipliers has great interest in the functional analysis. So the idea of generalized derivation is one of the most important area in the functional analysis. So in the year 2012, this Islamabad and Gahramani made the notable extension for the Stenker result, and in the setting of generalized derivation, and they proved the following result. Suppose A is unital and G from A into itself is generalized derivation, okay, related to D, means associated with A. If G is continuous, then every primitive ideal of A invariant under G. So this is what they generalized the result proved by the previous author for generalized derivation and the same setting. Further, in commutative version, this result theorem, this is the next result in the setting of the commutative version of the previous result when A is commutative. Okay, and moreover, they consider not only the continuous but arbitrary generalized derivation. So it also includes with discontinuous type maps. Okay, so when A is commutative and A is generalized derivation of A that maps into radical if and only if the representable as sum of ordinary derivation and the right translation by an element of radical. So what does mean? In fact, they describe the structure of generalized derivation on commutative Van-Allen algebra. That means generalized derivation on commutative Van-Allen algebra can be write as a sum of ordinary derivation and right translation means right multiplier. So that means every generalized derivation on a commutative Van-Allen algebra can be expressed as a sum of ordinary derivation and right multiplier. Then the Singer-Balmer conjecture also proved phi derivation. So this is what I'm not go and then I move because we not have much more time. We move some other type of things. That is, yeah, the idea for means same problem for left version set. That means in non-commutative setting. So if you look at the definition, an additive mapping D from A into itself is more general if we call linear mapping because we have algebra, so it's good if we call linear mapping. Is left derivation if this satisfies this condition, and we call Jordan left derivation if dx is y is equal to 2x dx, 2x dx. So of course, if you look carefully, the connection between left derivation and Jordan derivation, then every left derivation, Jordan derivation, however, conversely need not be true in general. This problem was classical problem and studied with several people in different settings. And then we come on, if we are talking about the a counter example. So if you look on here, this is the counter example because there exists a left derivation which are, so this is what the result if you look over here. Yeah, so A is commutative algebra with this condition x is equal to 0 and x by is non-zero. Okay, for x is different from y and we have map dx is equal to x a ax. Then this map is Jordan left derivation but not a left derivation. So the studying of Jordan left derivation is more interesting than the left derivation. So this problem has their own interest and a lot of work has been done on this area. But today we are focused only on the connection with the Singer-Balmer conjecture. Okay, so just we are come on. In the year 1990, Bresson and Bookman proved a result that is in the light of the Singer result that involve the continuity of our left derivation. So if Van-Allen algebra, let A is Van-Allen algebra, then every continuous linear left derivation maps into radical. This is the first problem, and then second problem is also due to the same author. And the problem is when this, dx x minus x dy belongs to radical of A, then D maps into the radical of A. And this is, the Singer-Balmer conjecture in the setting of Jordan derivation. The terms, the concept more than general than derivation. Further, in the year 2008, me and Professor Ashraf extended the notion of left derivation and defined the more general term, and we call it generalized left derivation. So the definition is as follows: an additive means and linear mapping G from R to R is called left derivation, or generalized Jordan left derivation if there exists a left derivation, respectively Jordan left derivation, such that gx by is equal to x g by and y dx. Similarly, if gx square is equal to x gx and x dy, of course there is a connection. If you note down, every Jordan derivation, Jordan left derivation is generalized Jordan left derivation. However, the converse need not be true in general, and we gave the counter example in the same paper. This paper was published in Bulletin of Coding Math Society in the year 2008, and also we established some result related to Jordan derivation and Jordan left derivation. Moreover, we characterize that in the another paper, every Jordan left derivation can be decomposed in the, that is, D and H, where D is a left derivation and H right centralizer. In this continuous, if you look at the concept of left derivation, I covered the concept of the left derivation as well as the right multipliers when you take D is equal to 0. Okay, and also it has I told you in last term, every generalized left derivation is Jordan left derivation. However, the converse need not be true in general. So this is the counter example, and the counter example is already given in the same paper. So somebody is interested, then go through that paper. Now, then we prove some result that make generalization of the classical result due to the Johnson and Sinclair. The result is the following. That is, all means there. If you have commutative, semi-simple Vanach algebra, then all linear derivations are 0. And similarly, Bookman extended this result in the setting of left Jordan derivation. So I just move quickly, and this is the result which we proved in the year 2011, and that is the continuity of semi-simple Banach algebra, and we study the relationship of Jordan left derivation and Jordan left derivation, generalized left derivation and Jordan left derivation. So in case of semi-simple Banach algebra, and G is Jordan left derivation with Jordan left derivation D, then every Jordan left derivation on A is continuous. So if you look on that that point of view, because why this semi-simple Banach algebra, basically we are purely algebraist is working on derivation in ring theory. Our interest is because once we consider the relation between rings and algebra, so all semi-simple Banach algebra are semi-prime. So this is the idea. What we means we are motivated how our results are interested, or we can apply in the theory of function analysis. So first, what we did, in fact, first we proved these results for semi-prime rings, and then we applied these results in the setting of Banach algebra or semi-simple Banach algebra, because every semi-simple Banach algebra is semi-prime rings, and hence we apply the results of semi-prime rings. These are some other results, and in this in the same paper we move, and now we come the another generalization. I think we not much time, so we come on the present problem. What we make connection with the recent work that is based on here. So in the year 1988, a well-known algebraist Hastin posed the question related to the minimum prime ideal of semi-prime rings, and that make connection with the old problem of Singer-Balmer. Okay, so look at the conjecture. So if P is prime, if P is a minimum prime ideal of a semi-prime ring, so look, that means we are moving from Bonner's algebra to ring theory totally side. So if P is a minimum prime ideal of semi-prime ring R, and dP contained in P, that means D invariant under P. Okay, when P is minimal prime ideal, with this minimum prime ideal, and moreover, then this result be purely extended in more general setting for see in other area. Just be move, I think, come on the main problem. That is what we are doing nowadays. Yes. So let us come on the problem. Let R be a ring of the bounded index M, and the additive order of every torsion element of R, if any, is strictly larger than M, then all minimum prime ideal of R are invariant under any derivation. So this result was, proved by Chong and Lee in the year 1984, and he also provided a counterexample. But we not do that, we come on our results. Okay. Yes. So quickly we move towards the new results. So we study these problems, in fact, in the setting of rings with involution. So what is involution? An additive mapping this from X to X star is called involution if these conditions are holds. So these are the example of involution, and identity map on any commutative ring, and let R be the ring of complex numbers, then define the conjugate of complex number. So these are the example of involution, and then these are some property of set of Hermitian element and isco-Hermitian element. And involution is said to the first kind if ZR contains HR. That means HR is set of Hermitian element. Otherwise, we call it second kind. In the second kind, ISR intersection ZR is non-zero. We use this property frequently. That's why we mentioned. This is another example, but we not do that. Okay. Then we define the high derivation. High derivation, the idea of the high derivation is given by, in the year Smith and Haas in the year 37. The definition is as follows. Let D be the family of additive mappings, DI from R to R, and D is said to be high derivation on R if this happens, and D and XY is equal to I plus J is equal to N, DIX and DJY for all XY belongs to R. Okay. And then we define that means we study the previous problems in the setting of high derivation. So what recently we proved the problem of the conjecture due to Hastin, that is proved in the setting of semi-prime rings. The result is the following. Let R be a semi-prime ring, then each minimum prime ideal M of R having a non-zero annihilator is DI invariant. That means the invariance property, the minimum prime ideals under the high derivation. Okay, so DI invariant, DI means the high derivation. If you take I is equal to 1, so it includes the concept of derivation as well. So this result includes the previous results as well. Similarly, we have the second result, but we move ahead. We discuss some applications, in fact, our results. So recently, in the year 2004, we proved the star version of Posner's result. Okay, what was the Posner's result? In fact, Posner proved that if D is non-zero derivation on a prime ring R, then dx dy minus x dy in center, then R is commutative. Okay, so we extended this result first for the star version. This is what we call dx x star in ZR for all x belongs to R with this condition. Okay, then R is commutative, and this result was generalized by in the year 2017. The result was published in Communication Algebra, and with the help of these results, okay, we gave the star version of Posner's second theorem for the high derivation in rings with involution. So let me state the result. Let R be a semi-prime ring with involution star of the first kind, and L be a star ideal of R. Next, let Di be a high derivation of n of R, which this condition hold, that is Dn x comma x star belongs to ZR for all x belongs to L. That means the star ideal. Then R is commutative ring or the section of Di. This result just published in Communication Algebra in 2023, and similarly we have the other semi-simple one-half algebra is semi-prime rings. Okay, so if we take semi-simple one-half algebra instead of semi-prime rings and apply this result, so we will prove this result in the setting of semi-simple one-half algebra. And if you take n is equal to 1, we obtain the result proved by the Bracer and the others, IJ Collery. So this is one of the most important result of this paper. This is Collery of the previous result when we take these equal to 1. Okay, so that means this result also generalized the result proved in Communication Algebra and the previous result me and my student Nadeem Dar. And then so as a conclusion, we conclude that the result we start this things from one-half algebra, means from the functional analysis, and we translate these results in the setting of ring theory. Okay, so and now we have a lot of problems, open problem related to this works, because there are a lot of functional entities based on this result are open problems, and if someone are interesting, then they can find these open problems in the paper that mentioned and published in Communication Algebra. So with this, I stop here, and now I hand over to Professor Kurle. Yes, Professor Kurle.
Yes, I am hearing. Thank you so much, Professor Shakir Ali. This is actually we together